question for you. What do you see? A turtle? A UFO maybe?
Well, for me, I see one of the most important clues to solving climate change: aerosols.
You mean this thing?
Well, yes, but also no. Aerosols are tiny solid or liquid particles suspended in the atmosphere. They can act as cloud condensation nuclei, which what it means is that they provide the surface for water to condense on. Particles can then form droplets, which are the building blocks for clouds. Check this out.
For this, you're going to need a couple of matches and a water bottle filled about 3/4 of the way up.
The next step is you want to shake vigorously, and what you're doing here is you are saturating the air inside the bottle with water vapor. After, you're going to light a match and put it inside the bottle. This will introduce aerosol particles inside the system.
So now when you squeeze and release, reducing the pressure and temperature inside the bottle, you can see water vapor condensing onto the particles, forming a cloud.
In the atmosphere, instead of a match, aerosol particles come from
Wildfires, car emissions, farming, and even meat cooking.
these tiny particles make their way up to the atmosphere and help form clouds. From particles to clouds. Cool stuff, right? But what does this have to do with climate change, you ask? Well, for the most part, the clouds that the aerosols create can reflect the sun's radiation away from us, cooling the Earth's surface. Kind of like those reflective sunshades that you put on your car window during the summer.
In some cases, these clouds can also absorb radiation and act like a blanket, trapping heat on the Earth's surface. In general, however, clouds have a cooling effect on our climate. But here's the caveat. The amount of cooling that clouds contribute to the climate is still uncertain. And to solve for that, it really does take a village. Some researchers observe cloud formation and their effects in the field on a large scale, whereas researchers in lab, like us, recreate aerosols and clouds to study the chemistry and physics behind what has been observed in the atmosphere.
The final step is to bring all these results and observations into a model that will assess the effect of these tiny particles on the climate.
Recent years have made it clear that collaboration between various expertise is now more important than ever to uncover every possible solution, mitigation, and adaptation method in combating the crisis of our lifetime.